All right. So, part 2.
Okay, I have to pull it up. Okay, here we go.
I'm going to do that after I finish. I want to do it.
I haven't wiped the camera down in a few days, so I was just gonna do it.
Okay, so number 6 is the same, one of the same. Didn't we have that question above?
They want to know what the 3 assumptions are. Number 4 was what are the assumptions for creating a confidence interval. This one is what are the 3 assumptions that need to be checked before you compute a confidence interval, which
Well,
I don't know what that means.
I think they're the same. No?
I don't know.
They're the same.
Let's just put that. They're the same.
Because when I did the reading, there was only one part that said anything about checking with 3 assumptions.
Yeah. I don't know about you, but when I read the math book, I just feel like I'm reading another language.
Yeah, most of the time.
It's the language of stats.
The only thing that really helps me is watching the videos.
Yeah, normally I watch the videos, but I didn't have time today. I literally texted you from the math lab, went to the computer lab to get SPS. Oh, I have SPSS.
God!
It didn't work.
Yes.
Wow.
I went. What?
They fixed it?
Yeah, the one that I bought and it never worked.
Yeah.
Went to the freaking computer help desk and this guy was like, "Oh, SPSS, huh? All right, we'll fix it." And I was like, "Glad I'm not the only one."
Yeah, my husband said that even when he took the class 3 years ago, that people with math always had issues with SPSS.
Yeah, that's what the guy said. That's what the guy said. So I felt a little better. It was like, validation.
Yeah, for real, right?
A little better. Then I went to the math lab. All right.
The math lab can be.
It was disappointing to say the least.
I really seriously cannot believe that they didn't have someone specialized in it, at least, that was hired there,
They might, and they might just not be working today. So I don't know.
It's so frustrating though when you're trying to get stuff done and you don't have someone there.
Right? I went and looked up appointments, and the appointments that they had available were Friday at 12:30, and I was like, yeah, I work then.
Online.
Work out.
How irritating.
Yeah, it's all right. Figure it out. Maybe it's meant to be.
Maybe. Well, what's your grade in the class right now?
My grade?
Yeah.
It's like a 77. It's not good.
So that's good. You're still passing as long as you pass, right? I mean, I know the whole GPA thing. I'm totally with you on the GPA thing.
Yeah, the GPA thing is killing me.
But as long as you pass, that's what matters. Right?
That's true. But I'm only halfway through the course, and I already have a C. So.
Yeah, but we just had a test too. So I mean.
Yeah, that's true.
I'm sure it'll even some things out. Okay.
All right. The GMAT is used as an admission criterion in many Masters of Business Administration programs. A BYU Idaho professor would like to estimate the population mean from a simple random sample of 50 people's scores. The sample mean for these 50 students is 541. Assuming a population standard deviation of 32, answer the following questions. What is the point estimate for the population mean?
That is the sample mean. So that is 541.
Okay, so on point estimators, yeah, I'm looking at the graph thing. So, yeah. They're called the point estimators. They're the so it's just really the perimeters. What? Yeah. Oh, interval. I don't know. Point estimates.
Point, point estimate. When I watched one of the videos, it just said his definition was basically the best point estimate of a population mean is the sample mean, and it's just one number, so it's the 541.
Okay.
So, number 8 says to create a 95% confidence interval for the population mean.
So we have to use that formula,
Yes.
the two, we use the two standard deviation divided by the n, or we use the x minus the m one. I think we use the 2 one.
I think we use whichever one. Do both of them you plug in? Is it both of them when you plug in the Z star thing?
Oh, the z star. Yeah, the z star is down. Yeah, that's the 95% confidence interval. You are correct.
You do the X bar plus or minus the Z star, which is 1.96,
Right.
and then you have that, and then it's like the, okay, so it would be 541. So 541, that's our mean, population mean.
And we have to divide it by the standard deviation, which is 32, divided by
1.96.
n, which is probably 50,
Square root of the n, right? So
square root of 50.
n, our sample size is 50.
Yeah. So I need to find the square root of 50.
Okay. So 541.
0, 7, 1, 7.0. Oi. I got a huge number. I did something wrong. Hang on.
549.
No. Okay, let's see. 541 minus 1.96 times I still got a really big number. I'm doing something terribly
Are you
wrong.
doing the plus or minus one right now?
The minus.
So you're doing 541 minus 1.96
Yeah.
times 32 divided by square root of 50. For that one, I got 532.130.
Yeah.
It's probably just because of how you're plugging it in your calculator.
It's very likely that. Okay. So
Because
standard deviation is 32 divided by the square root of 50, which was like 7.071. So for the standard deviation divided by the square root of 50, did you get 536.47?
I don't know. I just like, when I plug it in mine, I do the whole equation like I do 541 minus, and then I do a parentheses, 1.96 times parentheses 32 divided by square root of 50, parentheses, parentheses, and then I equal, and then it comes out the right way.
Awesome. I might get a real calculator. Laura, do you have a calculator?
Yeah.
Can I just borrow it?
Let me get the one I'm not using on my homework tonight.
Okay.
As long as you put all the parentheses in right.
swear my closet smells like cat litter.
Thank you. That's unfortunate.
I wonder if there's a hole in the wall.
Okay, so parentheses 41 minus 1.96 parentheses 32 divided by square root of 50. Okay, what did you get?
532.130.
Hmm.
So
This
are you,
time I got
does your calculator
2.439.
does your calculator have parentheses on it?
Does it what?
Does it? Can you put parentheses in, or do you have to do everything separate and plug it in?
No, I could put parentheses in, so I did that, but I got 2.439.
So do it like this. Put in 541 minus parentheses
Minus what?
minus, then put a parentheses sign,
Okay.
1.96, and
Okay.
then times, and then put another parentheses, like facing, still not like closing it off, but opening, like another opening parentheses.
Right.
32 divided by the square root of 50.
Okay.
Close off the parenthesis and then close it off again. Put two closing parentheses and then equal it out and see if you get the right answer.
I got 5.321. 300525 times 10 to the second 0 power.
Weird. How'd you get 5 points?
I have no idea.
So I mean, 532.130. But how did your decimal get in the wrong spot?
I just don't have any idea.
That is so weird.
Okay, let me try this one more time. Laura, is there some special setting that it's on that?
That only matters if you're thinking of degrees versus radians.
I just have no idea what she said. It's fine.
I feel you.
Oh, degrees versus radians.
Yeah, no, I heard you.
In a circle.
Okay. All right, let's try this one more time. Not getting this. Okay. 541. Stop doing that. You know, it may not be the tutors. It may just be me.
I don't think so.
I think so. Okay. 541 minus 1.96 times 32
Dang it. Put in the wrong number.
square root of 50.
No, that's not what I wanted. Oh my god.
Okay, I got the same thing. 5.321300525 times 10 to the 02nd power.
Well, I will tell you the right one.
All right.
Okay.
It's not that.
What's up?
X is the 41. It's the mean.
Okay. And then go back.
Minus the Z star, which is 1.96.
So when you're doing it, are you figuring out this and then subtracting it from that, or are you doing it in order?
I just plugged the whole thing in.
Because that might be the problem.
Then I'm plugging the whole thing in.
If I were you, I would find the square root of n.
Okay. What's that?
Okay,
What the?
so then,
Why does it keep doing that with everything I put in?
oh, that's just the calculator is.
Okay.
It might be a setting that I put in, but it's just like saying that there's no power. Okay, now the standard deviation divided by that. .07.
Okay.
Divided by 7.07. Okay, and then you're going to times it by the z star. Okay, and then whatever that is minus that number.
8.8. Same thing.
Really?
5.3219 times 10 to the 02nd power.
And what is it supposed to be?
What did you get, Shuri?
532.120.
So I'm off by like 100. Oh my.
Wait, let me make sure I got it right. You're like comparing it to me over and over again, and I like have the wrong answer. No, I got it right.
Hmm?
I did get it right.
Yeah, I know. Does it tell you on there how to get it?
No, it just says it just like has a formula like what we plugged in. You know, like 541 plus or minus 1.96 divided or times 32 divided by the square root of 50.
I'm telling you, I was totally doing that. Whatever. Okay. Just gonna go to this. Download that thing, because obviously I need it. Oh,
What was it?
it's the answer key. I try not to look at it till the end because it feels stupid. Okay. All right, let's just skip that one for now because I don't understand why I'm not getting the.
Sample size.
Say that again.
So the next one is just the same thing, but it's just a different sample size. So it's the square root of 100 instead of 50.
Let's try it. I'm really excited. 41 minus 1.96 times 32 divided by square root of 100. It's actually 10. Okay, I got 5.347.
Okay. So it sounds like you just have to move the decimal point over 2 spots and then you get it right.
534 is what you got?
Yeah.
Well then.
Let me check the calculator.
Probably. And on number 8, what did you get? 531?
532.130 and 549.89.
32.
And you were getting 5.32.
Yep, I was.
So, you know.
Okay.
Sounds
How
like your
does
calculator
the,
doesn't like you.
what's that?
Sounds like your calculator doesn't really like you.
Laura's calculator, it probably hates me for taking over. How does the margin of error for the 95% confidence interval of sample size 50 compare to the margin of error for the 95% confidence interval of a sample size 100? How does the margin of error for the 95
Oh, I did that one wrong. Okay.
size 50 compare to the margin of error for the 90?
532 to 534. So
There's like barely any difference.
it's really small.
So would it make a really big difference? I feel like it doesn't really make much of a difference.
So the margin of error. Okay, so on the answer key it says the margin of error gets smaller as the sample size grows larger.
Oh,
So
Well.
the higher number you have is like a smaller margin of error.
that's interesting. I would think it would be the other way around.
Well, I guess we learned something new.
Fair enough.
Okay,
Create a 90% confidence interval for the original 50 students.
so this is the same thing. We just have to plug in the different. So for 90%, that number is 1.45.
Yeah, the freaking. Just right now.
So we do 541.
So wait, we're doing the same formula,
Same
but
formula.
now we're doing the square root of 50 again.
We're doing square root of 50.
Oh, but it's for the 90. Okay, I get it.
Instead of 95, it's 90.
I get it. So 541 minus 1.645 times 32 divided by square root of 50. Hey, I got 533.5.
Yep.
Is that right?
That's right. Yes. Success. That's what you got, Sherry?
Yep.
What a beautiful
I was
day.
about to pull that
Peace.
calculator out of your hands and go switch it with mine. I didn't think it was working.
I was a little bit curious myself. All right. How does the margin of error for the 95 that you computed compare to the margin of error for the 90 that you computed? So for the 50 and 95, it was it was 532, and this one's 533.
Okay, so
So we have to find the pattern. So
well, I can just like compare like
so when it was 95, the 95% confidence interval was 532. The 90 is 533. So it went up, even though the percent went down.
okay.
Does that make sense?
I don't know why it does that. Margin of error. Okay, answer sheet.
Yeah.
Remember, the margin of error is just the second part of the equation. Therefore, in comparing the two margins of error, the margin of error for a 95% confidence interval is 8.87, while the margin of error for a 90% confidence interval is 7.7. Oh, I see. So they just like subtracted because you do plus, so like 541 minus 1.645 and then 541 plus 1.645 to get your two numbers,
Mm-hmm.
and they subtracted them to show that that's the difference for the 95% one and the 90% one.
Oh, that's right. I don't think I did that.
I don't know why. I guess I don't understand why they're asking us that though.
Well,
Okay,
yeah.
I gotta shut my door because all I can think about is Adele right
All you can what?
now. All I can hear is Adele. Hello.
That's awesome. Okay,
Okay.
So- so same thing. So as the margin of error, as the level of confidence gets bigger, margin of error gets smaller.
Margin, not margarine.
I said margin. Don't mess with me, man. I've had a crappy day.
You need some ice cream.
I need some beef jerky. Ice cream would do nothing for me. Or I need a taco.
Taco sounds pretty good.
Woo! Nice. Okay. The BYUI professor would like to repeat the experiment. Why? Why would he like to repeat the experiment?
He wants to torture us.
Because I have some meat.
Why did he want to do it in the first place?
I need to cook.
He wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure he has this level of accuracy for a 95% confidence interval? Okay, I'm not trying to cheat here, but I just saw the answer key. Mine only says students.
Mine,
Say how many.
I definitely have the correct number of students.
Okay. It's probably just mine then.
So, yeah, it gives me a number. It gives me 158. So we just need to figure out which
Confidence interval would be?
which equation we need to plug it into. That's what we need to find.
Isn't the equation the same? Isn't the equation the x minus?
No,
The-
because it's asking, because the other ones were asking for the margin of error, but this one, it gives us, it says they want the margin of error to be like 5. So,
Oh,
this time we're trying to figure out the sample size. So how many students does he need to make sure he gets that 95% confidence interval?
okay.
So
So we're
that
just plugging in a bunch of different sample sizes?
formula, that one is n equals z star times standard deviation divided by m, which is the margin of error,
I'm still not.
squared.
Yeah.
So we would need to say,
Yeah.
okay, so we'd say our mean
Hang on a second.
is 95%.
Do you have earphones or something I could borrow? My purple ones are still missing.
1.960.
I'm done with the sink. Do you want this still?
Yes. Everything in my life has gone missing, and what's not missing is broken. Thank you. By the way, Laura, this watch, it broke. I had to tape it.
No.
Yep.
Baking the rest of those cookies.
What in the world? Okay.
It's about time.
There we go.
I didn't get, oh, just kidding, I can swear it.
1 second.
Oh.
Oh my gosh, I got the right answer. I'm gonna cry right now.
Wait, how did you answer?
Okay, so it's what you have to plug in.
Say that again?
So it's what you have to plug in. So the formula, because you're trying to find the sample size,
Right.
is n equals z star, and our z star is 1.960
I always thought
times the standard deviation, which is 30.
do not stick them in the microwave that's metal on the ends.
Yeah, exactly.
And then
Pulverize it
divided by
with a knife.
the mark 5,
There's no good way to do it that I've found.
and then you square it.
Okay.
So you do 1.96 times 32,
That did it.
Right.
then you divide it by 5, and you square it. Then you get, I got 157.352. And whenever you do sample size calculations, you always round up. So it would be 158. And so that's how many students you would need in your study to get that confidence interval.
I should have taken it.
That is not what I got. Not even close. Okay, let me try one more time. Okay.
I just
1.96 times 32 divided by 5.
Making these toppers that I want.
And then you get that and you square root it.
No, you square it, like you multiply, you know.
Oh, squared. Squared.
Yeah.
That's why.
It's-
That's why. Okay, I got 2.5.
No, that's not right. Did you do the 1.960 times 32 and then equal that out and then divide it by 5 and then
1.96 times 32 times 5
Such is life.
square root. I got a massive number that I know is wrong. What?
Okay, try this. 1.960 times 32 equals
1.960 times 32.
so you got 62.72, right?
Yes.
And divide by 5.
Have the speaker stand up and they're like, thank you.
12.544.
Okay, then just do times 12.544
So I'll never know.
again.
157.35.
Yep.
I just wanted to know.
And then you round up to 158.
Why is this so hard for me?
Because calculators suck. That's why I use this calculator, Spencer. So my husband is always, my Spencer likes the standard calculator. I don't even know what it is. This one, like, he loves this calculator. Loves it. And
That's the
I
calculator I'm using.
hate this calculator
You hate it?
because, I don't know. He just loves this one because it has like all the basic functions like right there, easy. But
Mhm.
like, I love graphing calculators like this one
That's the one Laura's using.
because it like shows you, I don't know
When
if
did
you
you buy it?
Yeah, I can.
steps on it,
Yeah, I see.
and it has like the parentheses. So I'm like, I can see everything on there while I'm doing it. I don't know.
Doesn't get any older.
I think it depends on your personality, like which one works better for you. But
My personality is that none of them work well for me ever at all.
I think just math in general today is just not for you.
Can you tell? Like just not going in. Something's
One of those, it'll be
Yeah.
okay. I can pull us through the group.
all right. Let's take this group quiz.
But don't depend on me too much because I wasn't very confident when I looked at it earlier.
Well, thank you.
I just believe that you will do better than me. So
I wouldn't go that far.
I did complete the personal preparation. I was actively participating. I wasn't much help, but I was actively participating. Okay. Find the margin of error for a 90% confidence interval when the standard deviation. Okay. I think I should be able to do this. I
So it
should.
took me a little bit to find the equation to plug this one into. Because I did do this one. This is the only one I got done before we started our meeting. So
You've already done this?
no, just this one problem. I was
Oh.
looking at it before we started. Not any of the other ones.
Okay.
So I was trying to figure out which formula to plug it into because none of the other ones made sense to me.
Yeah, because we have a standard deviation and we have a sample size, but we don't have a mean.
So I found it, and the equation we plug it into is margin of error equals V star times standard deviation divided by the sample size, the square root of standard size. So it would be, so the 90%, our Z star is 1.645.
So the margin of error equals 2 times the standard deviation divided by the sample size.
It's just happened when I see what the main.
That makes sense to me.
No, I looked at that one and that one wasn't the right one, I don't think. Maybe you're right though.
Oh, that wasn't the right one?
Not the, I tried trying to figure that one out with that one. I don't know. I found a different one. It's like under the margin of error part. It's underneath. So it's on step 1,
Step 1.
and there's the big long one within the parentheses. And there's underneath that one it says margin of error.
Remember.
Z star. And that one made sense to me because we have all the information for it. But I don't know if that's right.
You try that one, and I'll try this one, and let's see if it comes out the same.
Okay.
It may not, because you know how good I am at this.
Well, let's
50
see.
You can actually
divided
tell,
by
well, sometimes.
the square
Tell when the cat is sick when their nose is really dry.
times 2. Okay, so I got 20.
See, I got
So-
16.45. But
Okay.
I don't know.
What? Why is life so hard? Okay, let's see here. 2 times 50 divided by the square root of 25. Still got 20. Good, good.
1 second.
Go try and find that
So you're
other one.
putting it in, so you're doing 2 times, what's our standard deviation?
50.
So you're doing 2 times 50 divided by the square root of 25.
Yeah.
Yeah, I got 20 when I did that one.
Okay. But 20 doesn't make sense because it says round to the nearest decimal place,
So
round
mine
3.
doesn't, well, and I plugged it in the other one either, didn't it? There, because I got 16.45, you know?
Oh. All right.
Wait,
Well,
are we trying to find, wait,
we're trying to find the margin of error. Margin.
we just plugged in, okay. So for that one, we plugged in, that says confidence interval. And confidence intervals are different.
So
than-
having tacos.
That's true. So we can't just find the margin of error because it's for a 90% confidence interval.
It can't be that one. It has to be the 16.45 answer because the margin of error equation is the Z star times standard deviation divided by the square root of sample size.
Yeah, you're right.
So, well, unless I'm like reading it wrong.
No, you're right because the margin of the one that I'm doing is in case we don't like we're trying to figure out.
I didn't know it until I tried once.
It's I'm not wording correctly here, but you're right
Okay.
because the 90% confidence interval makes a difference. I think
Oh, teething babies are terrible.
your baby's teething.
Yeah, it's torture.
I swear we probably have the weirdest video recording ever.
I'm sure we do. I'm sure he's like, can they stay on topic for like 1 minute? Just
talk
one.
to you about my dating life. You talk to me about your kids, and then we're like, oh yeah, math.
And then we are on number 4. Remember that?
Yeah, number 4. Let's do it.
Oh, I'm sure you can hear him like screaming in the background. He's, like, screaming. Okay.
Which of the
So-
following statements is true? Okay, I don't understand the difference between a point estimator and an interval estimator.
Okay. Point estimator. Okay. Point estimate.
I didn't even know.
The best point of estimate of a population mean is sample mean. That doesn't make any sense. Sorry, I can't really help you because I don't understand it either. So,
That's all right. Okay, so
but I can tell you that the first one I think is right. The mu is a point estimator of x plus.
Okay.
He is hungry. So we're only on number 4, and we have
You
have to check
it and see if the plastic come off and then take the rest of the plastic on it.
What do you need to go do, Shri?
Cameron, Spencer said Cameron is hungry.
Just squeeze one and it'll like slide
but
right
I
out.
don't think he's hungry.
I know it sounds weird.
He just wants to grab stuff from me.
If you need to go and feed him, you can totally do that and we can come back and do this. It's not like I'm gonna get any further, understand it any better.
Okay. Let me go and feed him. It only takes me like 15 minutes.
All right, just text me when you're done.
Okay.
All right, bye.
All right. Bye.
Is it gets messy.